Hi guys, thanks for checking out the channel. In this video, we're going to be taking a look at the plant room setup for an air source heat pump, the Viessmann 150. Okay, let me just give you a run through of the job so far. So we haven't actually filmed all the first fix of this. We are only going to be concentrating on the air source heat pump side, but let me run you through what we've actually done. So it's a full copper first fix. As you can see, we have actually insulated all the pipe work, although it probably isn't necessarily, as long as you're in that thermal envelope. And this is a bungalow that is being converted, so it's got a big loft conversion and the whole place is having a full refurb. So the underfloor heating that's installed on the ground floor is 16mm MLCP. It's at 150mm centers. Now, I did recommend installing like a cascolated panel or like the perforated plastic corrugated panels and try and get this down to 100mm, but the client was quite adamant they wanted insulated boards. So these are just like the aluminium, I think they're called EPS boards. So they're 20mm with a 16mm pipe, and that has all been pressurized and that is installed throughout the ground floor. Tyler's just beginning to put the Detromat down. And like I say, all the hot and colds and all the central heating for the radiators upstairs, the pipework is already installed and is in first fix location. This property is going to be complemented with an MVHR system, which isn't being installed by us, but it's pretty much all there. They've got all the first fix in, and we are now in the plant room beginning to get all the pipework and the internal components in and ready for this Viessmann Vitocal. So what we've got at the moment is we've got our copper first fix here poking through. Now it does look a little bit dull in colour. It's because the windows and doors have been open for a while, so it's starting to oxidise. They are supposed to be going in today, which would be great. So over here on the left hand side, we're going to have all our drops from our pipe work. So that will house our isolation valves, multifunctional valves for our hot water cylinder, etc. Now in here is our underfloor heating manifold. So we're going to be running this whole system open loop. Now, although I'm not going to go into too much detail in the design process of the air source heat pump installation, we're going to try and focus more on how to actually install it all. But this is all going to be running open loop, no actuators, no zone valves. If there's anything I've learned from all the learning that we've done and installing air source heat pumps, it's you want to keep it as simple as you possibly can. Try to avoid any zoning at all, and it will be a lot more efficient and it will work a lot better. So this is the internal unit for the Viessmann Vitocal, and this houses a mini buffer. It's got a display which plugs onto the front here, which we've taken off at the moment, and Bailey's just beginning to get it piped up. So off the bottom of this unit you actually have a flow and return which goes straight into your hot water cylinder, and inside is where the diverter valve is located, and then that will send it directly to our underfloor heating manifold and radiators upstairs. So a little bit different than your standard air source heat pump systems. There's no sort of 2 ports or 3 ports on the pipework itself. It is all controlled by this internal unit. And then through this opening here, we're going to be installing the air source heat pump down there on the corner, and then we're going to have our flow and return running along externally, obviously all insulated, coming through here underneath the MVHR unit, which is yet to be installed, and then straight into the unit here. So this video really, or the first part of this video, we're just going to show you how we're getting all the pipework in, what component needs to go where in terms of location, why we've chosen that component, and pretty much the process of doing it. So a lot of you watching, you might be experienced gas heating engineers like I am, and taking on some air source heat pump jobs can be a little bit daunting, but hopefully this video will show you it's actually quite simple, if not even easier than a gas heating system. So underfloor heating's all pressurized, all the first fix all pressurized. We've joined it all together on a manifold. I'm just going to drain it all down now, and then I can start dropping my towels down, getting my isolation valves on, and we can begin to pipe this system up. Okay, so we're heading towards the end of the first day and we're pretty much there with the pipework, I would say. So let me just run through with you what we've done so far and what pipe is what, etc. So on this unit here, on the internal Viessmann unit that comes part of the Vitocal system, so you get the air source heat pump that goes outside, and you also get this section here which is internal. So we've got the flow and return, which goes from the air source heat pump into the unit. So that's these two 28s here. So just clipped along the bottom. And as you can see, they're actually the center pipes of this internal unit. Now on the left hand side and the right hand side, we've got our flow and return for our central heating. So those pipes there, they just run down and then towards this underfloor heating manifold. And then we've just teed off for our radiators upstairs. So on a normal gas central heating system, at this point, you probably would have already chopped in a close coupled T or a low loss header, but we don't really need to worry about this because we're running it all open loop and we want the system to be sort of circulating as much as we possibly can. We just leave everything open with no zone valves and no actuators, and we shouldn't get any issues in terms of flow rate, as long as we've got enough head from the pump, which again is housed inside here, so we should be totally fine in terms of circulating. Now, you may have noticed that we're not installing any sort of buffer. Now, this whole system has been designed via Viessmann. We are doing this via their umbrella scheme, so we're not actually MCS accredited ourselves, but through the umbrella scheme, we can offer the bus grant, and what happens is they'll come out and carry out the inspection for us and the commissioning process. Once it's all done, make sure they're happy, and we can allow our clients to actually get that bus grant, which is great. So over here, I've just picked up these feeds that are dropping down, so just your standard stuff, hot, cold, balance cold. Over here on the left hand side, we've got some feeds going to utility rooms, so just run that behind the pipework here. So standard Viessmann cylinder, I would say. So these are actually quite new. So when I got the original quotation, it was actually a different manufacturer of cylinder, but Viessmann now do their own air source heat pump cylinders. But to be honest, they look very similar to an RM cylinder, so with a Viessmann badge on it. So yeah, multifunctional valve. We're going to finish off the other bits tomorrow. And like I say, in terms of piping this up, it's exactly the same as a gas boiler almost. If anything, it's easier. There's not as many components. We have got to add some things such as the filter. So you still need to have like a magnetic filter or strainer, which will go on the return. We're also going to add a flush and fill valve. So that's for adding in any chemicals, flushing out any debris, etc. from the system. And then that flow and return there, which will go to the heat pump, we need to punch that through the wall. So we're going to be using, I believe, a 75mm sleeve with 19mm sort of waterproof insulation. 28mm pipework will then run insulated all the way to our air source heat pump location once we've got the base in place. But in terms of piping it up, it's pretty simple. I think we've done really well. The connections underneath are a little bit peculiar. So you've got these like circlips, they have rubber O-rings on, and then you just have this copper spigot. So I have seen other engineers, they've just used like a press onto that or compression fitting, but we've just added isolation valves. I think it's obviously for service and maintenance a little bit easier. But other than that, it's very similar to like a 4-pipe system that you would normally fit with a Viessmann boiler. This will run on hot water priority, so rather than the flow of the heat going through like a 3-port valve, it just comes directly from inside here. We've got an ESBE valve or ESB valve inside here, and then what that will do is just send the flow straight to the cylinder. Once that's reached the demand, it will then allow the central heating to come on. So the underfloor heating and the central heating radiators upstairs, they're all designed to run at the same temperature. So that's why we've got no low loss header, no sort of separate pumps on each section, and we've also got no mixing valve. So the plan is to run this at the correct flow temperature, or the flow temperature that's been designed by Viessmann, and that should be equal across the underfloor heating and also the radiators. Now, that does sound a little bit risky to me. I have brought an SB valve just in case I do need to start mixing it, but it should be fine. We're obviously going to run this on weather compensation, and we'll set the curve down if we need to. This property is heavily insulated, so I'm expecting a good performance from this. So anyway, we need to pick up some parts for tomorrow and we'll be back to get this all finished and piped up. Okay, so we're just coming towards the end of getting all the pipe work in position, just buffing up all the pipes, and we have just discovered some Viessmann boxes that we didn't notice before. And for those of you who've been watching this video who are experienced Viessmann air source heat pump installers, you've probably been having a good laugh up to this point because we've totally forgotten to put a jig on the bottom of this indoor unit. So we put some isolation valves on there. We was kind of wondering why the spigot connections were a little bit odd, so we put isolation valves on there. We thought we had done a really good job, but as we've just discovered in this extra box we found, we've got this huge jig with brass components which looks like it's supposed to go on the bottom. So if ever there was a case of not reading the instructions, this is it. So what we're going to do is quickly whip off all these lever valves, get that jig on, and hopefully it shouldn't be too disruptive to our existing pipe work. Okay, so now we've got the jig set up correctly, I'll just run you through some of the internal components on this Viessmann unit. So we've got a 4-way diverter valve that will go to your hot water cylinder, so for hot water priority, your central heating or your underfloor heating, so your flow and return to that, your flow and return to your heat pump, but it also has this defrost buffer here, so if ever the temperature drops too cold and the air source heat pump needs to defrost, it'll actually heat up this stored body of water either via the element here, which is like a backup immersion, and send it back to the air source heat pump to sort of allow it to defrost. In here you also have an expansion vessel. Now we've actually added our own expansion just because we've got a lot of underfloor heating on this property, so we needed to sort of allow for that. And most of the stuff in here is pretty much just cables, and we've got a pressure relief valve here, so we need to connect that up. Comes with like a corrugated hose that you would expect to come with like your Vitadens 200, 150 for your standard gas boiler. So that's just going to drop through this jig here. There's a hole for it right there. So yeah, other than that, you don't really need to sort of mess around or play with it inside. All the wiring connections are underneath, and the pump is actually tucked in behind here. So this is a Grundfos 2575, so we should be fine for our head of pressure. So I'm not too worried that we're going to have any issues with the flow rate. So this front cover here, that just pops up like so. And then we've got the housing for our touch screen. So I just need to put that in place, get the white cover back on, and then that will just push straight onto there. Very similar to a 200 gas boiler. So we'll get that into position and then we can finish off all the pipework connections. Right, that is us pretty much piped up in the plant room now. So we've just got the coring through to do to break through to outside, but we are waiting on the sleeving, so we will save that for another video. So all we've got to do is drop the PRV down and then we will connect that up to this 32mm waste pipe here. So just to go through a couple of the components that we have installed. So when you buy the Viessmann air source heat pump, it will come with this Viessmann dirt separator. I think it's the Spirotech one, is it Bailey? Spirotech, Spirocross. Comes with the old insulation on it though, so that's cool. Put a flush and fill valve on it so we can put any chemicals and flush the system out through that there. And then we've got our hot water return pump. So the good thing about this system is you can control the hot water return pump via the display on the actual internal unit for the Viessmann air source heat pump. And that is over here. So gone for a Stuart Turner one. We use these quite a lot, never seem to let us down. So it seems to be a good bit of kit. Filling loop there just on the left hand side. And like I say, everything is able to be isolated. We've got the underfloor heating still pressurized, so we've just left that off at the moment, but we're pretty much ready to go. So what we're going to do is get those pipes through the wall, get the base done, and have the air source heat pump situated over there in the corner. And then the wiring should be pretty simple. So we need the sparks to actually provide us with power, but there is a sensor that comes off this unit here, goes straight into this dry pocket. So this is our sensor that will measure the hot water temperature, and then the whole thing is literally just going to be run off of weather compensation. So regarding the wiring for us, it's hardly an S-plan at all or anything like that, so it's nice and simple. So anyway, thank you very much for watching this video. Hopefully catch you on the next one.